mention anything. Just you can observe the question. Evaluate integral over s f vector dot n vector ds if f vector equal to xy I plus z square j plus 2yz k over the tetrahedron bounded by the lower limits x equal to 0, y equal to 0, z equal to 0, and the plane x plus y plus z is equal to 1. See here, we know that by Guass divergence theorem, surface integral f vector dot n vector ds is equal to volume integral div f vector dv. Here, they have given the f vector is equal to f1i plus f2j plus f3k. It is equal to xyi plus z square j plus 2yzk. Here clearly f1 equal to xy, f2 equal to z square, f3 equal to 2yz. From the div f vector means div f vector equal to del dot f vector equal to dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. Here f1 is differentiating with respect to x, it is y. f2 is differentiating with respect to y, it is equal to 2, it's 0. Y means it's 0. f3 is differentiating with respect to z is equal to 2y. Z differentiation is 1. Adding of these, dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z is equal to y plus 0 plus 2y. It is equal to 3y. Okay. Next, we can take the bounded values. The limits of x, y, z are z limits from 0 to 1 minus x minus y. Why? Because since the given plane is x plus y plus z equal to 1. So from this z equal to 1 minus x minus y. So z limits are 0 to 1 minus x minus y. Put z equal to 0 in x plus y plus z equal to 1. Then x plus y equal to 1. From this, x equal to 1 minus y. Sorry, y equal to, y can be changes to x, 1 minus x. Therefore, y limits from 0 to 1 minus x. For x limits, put y equal to 0 and z equal to 0. Then x will be 1. Therefore, x limits from 0 to 1. Integral over s f vector dot n vector ds is equal to volume integral div f vector dv. It is equal to integral x limits from 0 to 1, y limits from 0 to 1 minus x, z limits from 0 to 1 minus x minus y. Div f vector is equal to 3y. It is nothing but del dot f vector. This is 3y into dx dy dz. It is equal to x limits from 0 to 1, y limits from 0 to 1 minus x. Here 3y is treating as a constant. Why? Because the integral with respect to z variable means integral 1 dz is z, limits from 0 to 1 minus x minus y, dx dy. So it is equal to x limits from 0 to 1, y limits from 0 to 1 minus x. Upper limit is 1 minus x minus y. Here 3y is a constant function. This is 3y into 1 minus x minus y. Lower limit is 0 into dx dy. 3 is a constant right outside, x equal to 0 to 1. Multiply with y minus xy minus y square into here y limits also 0 to 1 minus x dx dy. Now we can integrate with respect to y. 3 integral x limits from 0 to 1. Here y integration is y square by 2, limit from 0 to 1 minus x again y limits y square by 2, integration is y square by 2, limits are 0 to 1 minus x, y square integration is y cube by 3, limits from 0 to 1 minus x whole dx. Okay, it is equal to 3 integral x limits from 0 to 1 minus x whole square by 2 minus x into 1 minus x whole square by 2 minus 1 minus x whole cube by 3. Lower limits all are 0, then it should be 0 into dx. It is equal to 3 integral x equal to 0 to 1 minus 2x plus x square, taking LCM of these two terms, 2 is the LCM, minus x into 1 minus 2x plus x square, a minus b whole square formula, minus 1 by 3 into a minus b whole cube, a cube minus b cube, plus 3ab square, 3x square minus 3ab square, 3a square b whole dx. 3 integral x limits from 0 to 1. Here 1 minus 2x plus x square minus x, minus into minus plus 2x square plus into minus x cube whole by 2 minus 1 by 3 into 1 minus x cube plus 3x square minus 3x whole dx. Here taking LCM, 3 2s are 6, 3 by 6 integral x limits from 0 to 1. 3 into 1 is a constant, minus 2x minus x minus 3x plus 3x square minus x cube minus 2 into 1 minus x cube plus 3x square minus 3x whole dx. See here, both are same terms. 1 minus 3x, 1 minus 3x plus 3x square minus x cube. 3 minus 2 is 1. So here 3 ones are, 3 twos are. It is equal to 1 by 2 integral x limits from 0 to 1. 1 minus 3x plus 3x square plus, minus x cube into dx. Here 3 minus 2 equal to 1. The same term taking common, the remaining are 3 minus 2 equal to 1. It is 1 by 2. Integration with respect to x, 1 integration is x minus x integration is x squared by 2. X square integration is x cube by 3. X cube integration is x to the power of 4 by 4. Limits from 0 to 1. It is equal to 1 by 2. Apply the upper limit, 1 minus 3 by 2. 3 3 get cancelled. plus 1 minus 1 by 4. It is the upper limit. The lower limit is 0 equal to taking the LCM 1 by 2 into 4 is the LCM. 1 plus 1 is 2. 2 4s are 8 minus 3 2s are 6 minus 1. It is equal to 1 by 2 into 1 by 4. It is equal to 1 by 8. Therefore, surface integral f vector dot n vector ds is equal to 1 by 8 is the answer. Okay.
Yes, ma'am.
Next problem, use divergence theorem to evaluate surface integral f vector dot ds. It's not f vector dot ds. F vector dot nds. Then only we are using the divergence theorem. Okay. F vector dot ds they have given in the question where f vector equal to x cube I plus y cube j plus z cube k. F, F vector dot n vector ds. Then only we can apply the divergence theorem. Without n vector we cannot. And S is the surface of the sphere, x square plus y square plus z square equal to r square. Here you should remember when they have given the sphere surface or circular surface, then better to go for the polar form only. Why? Because the integral is related with the surface to volume, means in the volume, three variable values are there, that is x, y, z. But here we can transfer to r square minus the limits, z limits from minus of under root of r square minus of x square plus y square. Its simplification is very tough to integrate. We are taking with the x, y, z variables. So better to take the conversion of the polar form. You remember that. Okay, if whatever they have given x square plus y square equal to a square or x square plus y square plus z square equal to r square, you should transfer to polar form. We are taking the three-dimensional polar form. Okay, first using the divergence theorem means by Guass divergence theorem, surface integral f vector dot n vector ds is equal to volume integral div f vector dv. Okay, here given f vector equal to f1i plus f2j plus f3j. Here they are asking about the value using the divergence theorem, not verification. If they are asking the verification, means we can find out the LHS and RHS separately. You remember that. X cube I plus y cube j plus z cube k. Here f1 equal to x cube, f2 equal to y cube, f3 equal to z cube. Okay, f1 is differentiating with respect to x, 3x square. F2 is differentiating with respect to y, 3y square. F3 is differentiating with respect to z, 3z square. Adding three terms, dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z is equal to 3x square plus 3y square plus 3z square. It is equal to 3 into x square plus y square plus z square. They have given x square plus y square plus z square is equal to r square be the surface of the sphere. So in the place of x square plus y square plus z square, we can write it as r square. So it is 3r square. This is equal to del dot f vector. Okay. By the divergence theorem, we can take the surface integral f vector dot n vector ds is equal to volume integral del dot f vector dv is equal to integral r integral theta integral pi 3 r squared d theta d pi dr. This is the value. But here we can take the dx, dy, dz. First we can take, it is the x limits, y limits, z limits. After the conversion, we can convert into dx, dy, dz equal to what is that? Here, x square plus y square plus z square is equal to r square. It is the sphere equation. This is the sphere surface. When it is sphere surface, we can convert into polar coordinates, changing the polar coordinates. In the polar coordinates, how we can take the x, y, z values. Here, first we can take z is equal to r and y is equal to, here z cos theta. Why? Because in general, x equal to a cos theta, y equal to a sin theta. Here z equal to, we can take smaller cos theta. Y, for y and x, the cos theta is same. For x and y, cos theta is same. Okay. Here z equal to smaller cos theta. When we can take x equal to a cos theta, then y can be changes to a sin theta. So cos theta opposite ratio we can take. Here also for y, we can take r sin theta. X is also fixing r sin theta. Okay. But here again angle is changed. Why? Because it is 3-dimensional. X, Y, Z is related with the theta, then X and Y both are related with the another angle pi. Okay. Here we can take X equal to cos pi, Y equal to sin pi. Is it clear?
Yes, ma'am.
Z is fixed, Z is equal to, we are taking R cos theta. Z equal to R cos theta means cos theta is perpendicular to, both are mutually perpendicular. If when it is perpendicular, we can take cos theta is changes to x and y, then those are r sin theta, r sin theta. Next, for x, we can take cos pi, for y equal to sin pi. Again, cos x and y both are opposite, cos pi changes to sin pi. It is the polar form in the 3-dimension. In this, what are the values or what are the limits? Here are limits from 0 to r only. Why? Because we are taking radius is r. Okay. It is the x square plus y square plus z square is equal to r square. That is nothing but limits from 0 to r only. Okay. And here theta. Theta is limits from 0 to pi. Theta limits from 0 to pi. Why? Because it is the sphere. Sphere means we are taking the z coordinate is perpendicular to x and y. So it is horizontal line. Horizontal line means we can take 0 to pi only. Next, pi limits from, it is circle. That is the circle form. Why? Because x and y is making a circle. But z is the base. That is the axis of the z. So it's 0 to 2 pi. Clear? Limits are
Yes,
also
ma'am.
0 to r, theta 0 to pi, 0 to 2 pi. Next, again, we can calculate the dx, dy, dz is equal to, what is that? Again, we can go through the partial derivatives. Those are just here. Dx is differentiating with respect to r, that is the cos pi sine theta. This is dx by dr. Dx by d theta equal to r cos pi sine cos theta. Dx by d pi equal to minus r sine pi sine theta. Okay. Dx equal to r, theta means cos pi sine theta, cos theta. Okay. Is it clear? R differentiation is 1, sine theta differentiation is cos theta, and the cos pi differentiation is minus sine theta. Next, y is differentiating with respect to r, sine pi sine theta. Dy by d theta equal to r sine pi cos theta. Dy by d pi is equal to r cos pi sine theta. Dz by dr equal to cos theta. Dz by d theta equal to minus r sine theta. Dz by d pi equal to 0. So Jacobian function. Dou of x comma y comma z by dou of r comma theta comma pi is equal to determinant cos pi sine theta r cos pi cos theta minus r sine pi sine theta sine pi sine theta r sine pi cos theta r cos pi sine theta cos theta minus r sine theta, it's 0. Okay. This simplification is need not, but how we are getting that value is, for that only I am explaining you. Here, I am taking the last row. Why? Because it is 0. So, plus minus, plus minus, plus minus, plus. So, cos theta into elimination of row and column, r into r square, cos square pi. Here, it's not pi, it's theta. Cos square pi, cos theta, sine theta, minus into minus plus r square, sine square pi, cos theta, sine theta, minus into minus plus r sine theta into elimination of corresponding row and column, r cos pi, cos square pi, sine square theta, minus into minus plus r sine square pi, sine square theta. It is equal to r square is common, and cos theta, sine theta is also common. Already here cos theta is there. Cos square theta, sine theta. The remaining terms are cos square pi plus sine square pi plus r. Here sine square theta common, r is common. So r square sine square theta into sine theta, sine cube theta. The remaining are cos square pi plus sine square pi. These are 1. So again taking common r square sine theta, then it is cos square theta plus sine square theta. So d dou of x comma y comma z by dou of r comma theta comma pi is equal to r square sine theta. From this we can write it as dx dy dz equal to r square sine theta dr d theta d pi. Okay, this is the relation of the polar form with the xyz and r theta pi. So what here we can write it as dx dy dz equal to r square sine theta into dr d theta d phi. Is it clear?
Yes, ma'am.
So, but the simplification is no need. You should take the polar coordinates z equal to r cos theta, y equal to r sine phi sine theta, x equal to r cos pi sine theta, r limits 0 to r, theta limits 0 to pi, pi limits 0 to 2 pi. Okay. dx dy dz is r square sine theta dr d theta d phi. Now we can take surface integral f dot n ds is equal to volume integral 3r square dx dy dz is surface integral f vector dot n vector ds is equal to volume integral 3r square dv. It is equal to integral x y z 3r square dx dy dz equal to r limits from 0 to r, theta limits from 0 to pi, pi limits from 0 to 2 pi, 3r square, r square, sine theta, dr, d theta, d pi. It is equal to 3 r square into r square, r to the power of 4, r equal to 0 to r, theta limits from 0 to pi. Sorry, here we can't write outside, only 3 we can write outside. It's r power 4 into sine theta. Here dr d theta, but integral of pi is pi. Integral of 1 d pi is pi, limits from 0 to 2 pi, dr d theta. It is equal to 3 integral r from 0 to r, theta from 0 to pi, r to the power of 4, sine theta into 2 pi minus 0 is 2 pi, dr d theta. It is equal to 2 pi right outside, 6 pi integral r equal to 0 to r. Sine theta integration is minus cos theta, limits from 0 to pi, dr equal to 6 pi. Sorry, here r to the power of 4, cannot forget. 6 pi integral r equal to 0 to r, r to the power of 4 minus cos pi, minus into minus plus cos 0 into dr. It is equal to 6 pi integral r equal to 0 to r to the power of 4. Here cos pi is minus 1, minus into minus plus 1 plus cos 0 is 1 dr. It is equal to 2 is right outside, 6 2s are 12 pi. R to the power of 4 integration is r to the power of 5 by 5, limits from 0 to r. It is equal to 12 pi r to the power of 5 by 5 units. It is the answer. See here, the similar to previous problems only, use divergence theorem to evaluate surface integral f vector dot n vector ds, where f vector is 4xi minus 2y square j plus z square k, and s is the surface bounded by x square plus y square equal to 4, z equal to 0 and z equal to 3. It is similar to z equal to 0 and z equal to b, and x square plus y square is equal to a square form. In this, you can take the limits of y is equal to plus or minus under root of a square minus x square. Okay. You can find out the
Yes, ma'am.
evaluate. Use divergence theorem means we can write it as surface integral f vector dot n vector ds is equal to volume integral div f vector dv. Div f vector dv means that is dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z, and z limits from 0 to 3, x y limits from minus under root of a square minus x square to plus under root a square minus x square, x limits from minus 2 to 2. Here in the place of a square we can take 4 minus x square minus under root plus 4 minus x square. Here x limits from minus 2 to 2. Next, it can be after the z integration, it's constant, no problem. After the y integration, it should be converted into somewhat 4 minus x square dx with the multiple of x. In that case, in the previous problem, we can take x equal to a cos theta. Now here you are taking x equal to a sin theta. A is nothing but it is 2. 2 sin theta you have to take. In the place of a, theta, in the place of a is 2, theta limits from 0 to pi by 2. You are getting direct positive limits only. Okay. Why? Because the lower limit is 0 means we can take sin theta is 0 when it is 0 degrees. X equal to 2 means 2 get cancelled. Sin theta is equal to 1 when it is pi by 2. Is it clear?
Yes, ma'am.
So you are getting the positive sign of the area only, no negative. So better to take x equal to a sin theta. Is it clear?
Yes, ma'am.
Okay. Next, it is f vector dot n vector ds, where s is the surface bounded by the cone. Cone means in the place of z square, you should write z equal to 4 means 16. Same similar to above only. The limits of z from 0 to 4 and the y limits are 16 minus x square plus or minus under root, and x limits are plus or minus 4. So it is also, you can take polar form. In the polar form, x equal to 4 sin theta. Okay. If you need in the calculation, if under root means better to take the polar form, then the root is eliminated. You are getting the answer with the real values. It is simple form. So when they are using they have given the circle equation or sphere equation, you choose the polar form only. Why? Because the values are simple, are real values. Theta also 0 to 2 pi, or pi is equal to 0 to pi. What we are choosing the way, that is the thing. Okay. You do these two are homework.
Yes, ma'am.